Welcome to my YouTube and Facebook channel. In this video, we will discuss about protons to power next, gene memory devices, and neuromorphic computing chips, revolutionizing the future of technology. Introduction. In the ever-evolving landscape of technology, innovation is the driving force behind groundbreaking advancements. Enter the era of protonic electronics, a remarkable field that harnesses the power of protons to create next generation memory devices and neuromorphic computing chips. As the demand for faster, more efficient, and energy-saving computing solutions rises, scientists and engineers are turning their attention to protons, a subatomic particle that has the potential to revolutionize the future of technology. Join us on this thrilling journey as we explore how protons are powering the next gen memory devices and neuromorphic computing chips, unleashing the power of proton. At the heart of protonic electronics lies the manipulation of protons as carriers of charge. Similar to electrons in traditional electronic devices, while electrons have been the workhorse of electronics for decades, they face certain limitations, particularly in terms of speed and energy efficiency. Protons, on the other hand, offer exciting new possibilities due to their unique characteristics, such as high mobility and the ability to tunnel through materials with ease. Protonic memory devices, a quantum leap in storage. Protonic memory devices have emerged as a groundbreaking alternative to conventional memory technologies, such as flash and DRAM. By exploiting the movement of protons through specific materials, researchers have developed novel memory cells with the potential for ultra-high storage densities, faster read, write speeds, and lower power consumption. One of the most promising protonic memory technologies is the proton conductive oxide, PECO memory. PECO memory cells use protons to modify the electrical resistance of the material, thereby storing data in the form of resistant states. This approach enables data retention even when the power is turned off, leading to non-volatile memory with significantly reduced energy requirements. Imagine a future where your devices power up instantly, store vast amounts of data, and never lose information due to power failures. Neuromorphic computing chips, bridging the gap between man and machine. Neuromorphic computing seeks to replicate the brain's architecture in silicon, offering a revolutionary approach to artificial intelligence and machine learning. Protons play a pivotal role in enabling neuromorphic computing chips to mimic neural networks efficiently. Neurons in the human brain communicate via ion channels, where protons are one of the critical ions involved. Scientists have cleverly leveraged this biological phenomenon to develop protonic neuromorphic devices. These devices use protons to represent synaptic weights, the connections between artificial neurons, and process information similarly to the human brain. As a result, they can perform complex tasks like pattern recognition, decision making, and learning with astonishing efficiency. Benefits for a sustainable future. The integration of protons into memory devices and neuromorphic computing chips has far-reaching implications for sustainability. By consuming less power, these protonic technologies can significantly reduce energy consumption in data centers and electronic devices, lowering our carbon footprint and helping combat the challenges of climate change. Furthermore, protonic electronics have the potential to extend the battery life of portable devices, making renewable energy storage more efficient and powering energy. Conscious IoT devices in smart cities. Conclusion. As the world delves deeper into the digital age, the demand for high-performance, energy, efficient computing solutions intensifies. Protons are emerging as the next big thing in the world of electronics, holding the key to unlocking unparalleled advancements in memory devices and neuromorphic computing chips. With their superior properties, protons promise to revolutionize technology, paving the way for a more sustainable and intelligent future. The journey of protonic electronics has only just begun, and its impact on our lives will be nothing short of transformational. As researchers continue to innovate and unravel the full potential of protons, we eagerly anticipate the day when proton-powered devices become an integral part of our everyday lives. The future is bright, and protons are illuminating the way. Thanks for watching. If you like video, please subscribe, give feedback and comments, and share with others.